You're also probably wondering, well, you said it's only at 1 atmosphere. What about other pressures? And we do have those. Here's some examples right here. They're just not used as often because usually we're keeping everything at 1 atmosphere. Aside from using binary phase diagrams, we also have ternary phase diagrams, and that's where it gets a lot more complicated. So in this case, we have 3 different compounds that we're looking at, and that can either be metals, or the other place you'll see it oftentimes is in ceramics. And on a 2D surface, they're hard to demonstrate, but they kind of look like this when you're looking at it from a 3D perspective. And again, this is only with temperature and then those 3 different compositions. So there's a couple of ways of approaching it. The most common one you'll see is you will pick a specific temperature, and then you can see all 3 compositions. So it'll look like this kind of triangle, and you can go through and figure out what phases they are. Or you'll set one of those 3 compounds at a specific composition, so say like 20%, and then the other 2 can be varied and varying in the temperature, so it looks again like a normal phase diagram. So that's a lot of what you'll see with these ternary phase diagrams. There's actually Professor Sun at University of Michigan has actually used a VR headset to demonstrate what it would look like walking around one of these phase diagrams, one of these ternary 3D phase diagrams, where you can then take these different slices of the temperatures or compositions that you are curious about. And if you're wondering about like high entropy alloys where you start to have 4, 5, 6 different elements, that's something we're still very actively working on because we're just not sure. Most of the time when you see work, they usually end up setting a couple of different compositions and they start to iterate through as they vary it along, so we get these multiple snapshots as you go along. But this is still very early stages.